everyone. My name is Maytal Dahan. I'm one of the co-PIs of SGX3. Today we have a really exciting webinar for you. The SGX3 summer interns are going to talk about the last 9 weeks they've had at TAC. Just a reminder, SGX3 is a center of excellence for science gateways. We have a wide variety of services from technical consulting to outreach to our Gateways conference that's going to take place soon. To community surveys, we can help you with proposals. We do things like usability and sustainability consultations. So we would love for folks to reach out if we can offer any services for you. So a little bit about the internship for those of you who don't know. So SGX3 has a 9-week summer internship. This takes place in Austin, Texas at the Texas Advanced Computing Center, and it's really targeted for graduate students to get hands-on experience. Students get a chance to work on cutting-edge science gateway software and services, and they're embedded within the Advanced Computing Interfaces department at TAC. The goal throughout the internship is really to have invaluable skills when it comes to actually doing software engineering and technical skills, in addition to working within a team, learning best practices, learning some of those soft skills in addition to the technical skills. It's really an opportunity to have both new technical knowledge, hands-on opportunities, and collaborative opportunities as well. If you're interested in 2025, we really start the process pretty much as soon as this internship ends. You can go to sciencegateways.org/internships and subscribe to our newsletter. And I think applications come out as soon as October or November for 2025. We've also done in the past where folks can sponsor interns. If that's something of interest to you, please reach out as well. So we have 6 wonderful interns this summer. This is the order in which they'll be presenting today. I'm really excited to have everyone see their presentations. We only have an hour, so we're going to go ahead and jump right in. Sajith, are you here? Yeah, great. Sajith, Claire's going to give you control of the slides, and you can use the arrow to click through them.
Sorry, the laptop has been glitchy, so like it's just taking forever for me. And
great, we hear you. Go ahead.
Okay. Good morning, everyone. My name is Sajith. I've been part of the SGX3 internship program, and I've done my master's in computer science from Indiana University and bachelor's in information technology. And I've been part of the WMA team at the UT Austin TAC, and it's been a wonderful team headed by Tracy Brown. And I had the privilege of working with Nathan, Frank, and also one of my fellow intern, Beulah, who have all been instrumental in guiding me through this project. Let me introduce you the Recon portal. The Recon portal is an interactive world map designed to track the natural hazard events around the world and providing access to the related datasets for all the researchers to know more about any of the events that have been happened over. And our goal has to be achieve the interactivity of the portal and make it more functional and advanced for the users so that they could learn more about the portal. The primary goals for my project has been to integrate open topography data, such as the LiDAR data sets into it, and also to transition from the legacy Angular JS to React TypeScript and enhancing its functionality as well as its performance. And over the past 9 weeks, I have achieved several key milestones, from learning the TAPIS framework to integrating complex datasets, and finally converting the parts of the Recon portal to React. Each week brought me new challenges along with a few new learning opportunities. In the first 2 weeks, I focused mostly on completing the tutorials and familiarizing myself with the TAC, a lot of HPC resources that they have. And this laid the groundwork for my future works, which I could pass through easily. Yeah. And week 3 involved mostly exploring the various geospatial data formats and understanding the open topography data. This exploration was very crucial for us to understand the mapping of the data integration requirements, and also being new to the geospatial geographic data, getting my head around it was crucial part of it. And during the week 4, I have successfully integrated the open topography data into the Recon portal using the GeoServer API, achieving 80% of our integration requirements. And this was accompanied by a documentation and the presentation for the WMA team. In the next following week, I had to integrate with the feedback from our WMA team and along with the open topography team, which the feedback included we are not allowed to use the integration that we have done in the prior week, and which led to creation of our own data sets and host them in our own, own servers and create our own endpoints to access those data, which led to the starting of creating scripts to fetch the files from the automatically fetching the files from the GitHub. And next week, I have developed a script for data processing and creating Django endpoints to serve this data, which automated the data fetching and ensured the endpoints for seamless front-end integration. In this week, I've added many more like the advanced features such as the polygon mappings that you could see, and also the other interactive features such as pop-ups, and which give the detailed summary or overview of the related data in this, and which I actually had a great impact on the usability and the interactivity of the whole portal. And the coming to the week 8, we had got a feedback from the open topography team that we got a new API that has got the new feature rich enhancements, and which led to the integration of this new API. And along with that, I was able to add few more integrations such as the color coded mappings, and also enhance the performance by using backend caching, which had a significant improvement in the performance of this portal. Coming to the last week, I started converting the React portal from the Recon portal to React from AngularJS, and achieving the feature parity what it had in the terms of mapping and few additional features, and which has also had a very significant impact in efficient querying capabilities. And coming to the main challenges were the API limitations and the need to reintegrate the data multiple times. If you see, I have gone through, like I said, through 3 times during the initial week 4, week 5, week 6, the same things, integrating it again and again. Due to the feedback from the open topography team, we had to go through multiple iterations of each of those. Each time we are using different backend to get the data. These obstacles taught me the importance of the adaptability that we need in this field of software development. And I gained a deeper understanding of the geospatial data and the TAPIS framework, learning how to integrate complex data sets and handling API constraints effectively. Coming to some memorable moments that I had, one thing that I had to share is from the Nathan Freeman, the mentorship, when he had, if you could see the whiteboard, like the whole thing was drawn by him. When I got a small doubt, he took a whole lot of more than an hour to explain the work that he have done over the past 2 years in exclusive details. And also the talks from the director, Dan at TAC, those were like, I really enjoyed those talks. Like he used to mention those small cues of technical details whenever he used to go through some of the things in the staff meetings. Those were like really cool. And not to mention the SEC event that was hosted by UT. It was great. Like I really enjoyed myself over there. And the integration workflow included through the research, implementation, optimization, and ensuring the feature parity and performance in the portal, which was in like an overview of straightforward way, but multiple iterations of it in each week that I had to go through. And overall, I successfully integrated the open topography data, converted the portal to React, and performance improvement and interactivity, and which led to the goals that I've set for myself and the brief that I was given during my task as an internship. I was able to go through all of those. And looking ahead, I'm trying to refine these integrations and also add few more data sets so that the researchers can use the portal much more efficiently than it has been now. And in conclusion, the internship at TAC has been invaluable in enhancing my skills and providing deep insights into real world applications development. And special thanks to Metal and SGX3 team and also my mentors on the WMA team for their support constantly going through each of the weeks and helping me guide to the right path. And that's it from my end. And thank you for all for joining us. And if you got any questions, I'm happy to answer those.
Thank you, Sadiq. We're going to save questions to the end to see if we have enough time.
Yep, thank you.
Hello, everyone. My name is Beulah. I am a recent graduate from the Ohio State University. I got a master's degree in computer science with research focused on machine learning and speech processing. With a background in computer science and engineering, coupled with experience in neural networks and machine learning, I was always passionate about working on projects that bridge the gap between research and real world applications. And what better place to do so than at tech, which has endless opportunities to learn and explore. I got to know of this opportunity through Icicle, which I was a part of during my college. And when I interviewed with Meetal and Tracy, we had a great time talking about the available projects and sharing project experiences. I was extremely happy to know I was going to be a part of the Longhorn family, and here I am, all excited to share my learnings and experiences as an SGX3 intern at Tech. During my internship, I had the pleasure of working with the web and mobile applications team where Sajid and I worked on the Design Safe project. We were directly mentored by Nathan and Frank and managed by Tracy, but indirectly the whole team was a part of our internship journey. Our goal was to enhance the Design Safe Recon portal's capabilities for better natural hazard research. The Design Safe Recon portal, as mentioned by Sajid earlier, is a web-based platform that facilitates the exploration and analysis of natural hazard events. It provides an interactive world map and access to various data sets, enabling researchers to visualize, access, and analyze natural hazards. Our main objective for this internship was to enhance the portal's capabilities, include data from open source APIs, provide a more comprehensive understanding of these natural hazard events, and improve user experience and developer flexibility. We aim to integrate topographic data, improve platform robustness, and user experience. In the first month, we started off with onboarding and trainings where we met with the team members to know of the existing workflow and system design. We then finished Tapis and JavaScript tutorials and setting up my local development environment. We then started exploring open topography APIs. We built a prototype pipeline for data mapping and retrieval and presented the progress to the team. I was always keen on knowing the team's thoughts and discussing the pros and cons of the current pipeline design. Because of the multiple possibilities we had, we started our divide and conquer approach. So me and Sajid started exploring two different ways of integrating the data into Recon portal. By the first week of July, we came up with a JSON format to include all the necessary fields from the API which were useful to integration. I created some test data in the defined format to analyze the change in the workflow once we have the actual data ready. Next, we moved on to the actual data and started integrating open topography API calls. We realized that their data was present in two different places, and I was able to add some Python scripts for efficient data retrieval and pre-processing to get a comprehensive output. Next, I started working on storing this data in design safe community data place and retrieving it to the web applications through Tapipy. This Tapipy is a Python library for interacting with an instance of the Tapis API framework where we create system clients and use the system clients for file retrievals. This provides safety and ensures safeguarding the data integrity and streamlining research workflows. During this time, I had the opportunity to work with unit tests in Python to test the data flow and system modularity. Towards the end of my internship, I moved toward front-end development and UI detailing, and I was able to include some advanced filtering capabilities, enabling researchers to refine their search with precision. And we also repositioned some elements on the UI for a refined look by moving the position of filters to the top of the map sections for better user experience. I faced challenges in understanding REST APIs in the initial days, and we were constantly dependent on the open topography team. And I would say I had some new learning experiences, which was kind of challenging to understand such a complex module like TAPIS and understanding its flows and which parts of TAPIS could be integrated and used for our use case. However, I overcame these challenges with consistency in learning and adapting to new technologies. Out of the many lessons I learned during my internship, several valuable lessons were firstly brushing up on basics like JavaScript and React, which were crucial before diving into new technologies like TypeScript. I realized that defining project level data storage structures is very efficient for long-term success, and that leveraging team mentoring and communications is vital for internal insights. Many things are learned with experience, and when we have our mentor sharing their learning experience with us, it gave us a boost and reduced many trial and error loop runs. Using a divide and conquer approach is effective in research, and overcoming open source API integration challenges requires little patience. I also learned that consistency is key for front-end development and that constructive feedback and regular team meetings are essential for growth. And additionally, I gained confidence in my abilities, particularly in front-end development and API integration. I learned to appreciate the value of feedback and collaboration, and I'm grateful for the support and guidance I received from my team. I had several wow moments during my internship, including all the team meetings, the constructive feedbacks, and words of praise. I also greatly enjoyed the tech tour, great talks from the team, and time exploring Texas. Some of the memorable moments we have are here: how my team celebrated the small milestones we reached as we progressed through our internship. It was a great feeling to know how my hard work was paying off and that I was contributing to the team's efforts. This was a wonderful opportunity to work with a talented team and learn from their experiences. And outside of work, I explored some great places in Austin, did boating on the Colorado River and watched the great sunset view, hiking on Mount Bonnell and watching the fireworks at the UT Austin Tower. I should mention this for sure. Casually, we asked Mike yesterday during lunch about gifts to take back from Texas, and he immediately went into action and offered us a lot of tag swag. Not to mention how much I love collecting swag, I was extremely thankful. The food and vibe of Texas are always a bonus. Everything is big in Texas, and so was a dictionary at library, which literally had my name and 3 different meanings for my name. There is a picture on the slide, but I don't think we can zoom in and see my name was there in the dictionary. But in conclusion, my internship experience was enriching and challenging. I am grateful for the opportunities I had and the lessons I learned. Thank you to my team, my mentors, and TAG for supporting me through my journey. And this is my Texas story.
Thank you, Bila. What a great presentation. Thank you for the hard work you and Sajid did on open topography. It's wonderful.
Hello, everyone. My name is Rahil, and I'm a PhD student in computer science at North Dakota State University. I worked in TAPIS UI features in support of Icicle to create a user-friendly interface of MLHub in TAPIS UI, which is integrated to Hugging Face Models API for non-technical users. This allows to view the details for available models or data sets on Hugging Face based on the prototype. The team that I had the honor to work with was the CIC team. I worked with Joe, Nathan, Danny, Gilbert, and also Alex. That I'm very grateful that works with them. The goal of my project was to create an inference server info page for model details in a model details page, which is triggered button, and to create a front end for database datasets API, to create a main datasets page that lists 100 most downloaded datasets on Hugging Face, to create also a datasets detail page, and layout to button features for datasets card and download datasets on that page. Also to create a page for each of these button like dataset cards and download datasets. I started my internship by some learning and training tutorial on web development tools. In JavaScript and TypeScript language, React library, Node project manager, HTML and CSS, Git and Figma. I familiarized myself with Tapestry UI framework and high-performance computing and learning models, inference, models and datasets API, and also working on small tasks. And great workshops that we had at the beginning of the internship. My first task was to create a component to fetch inference server availability to show if the inference server is available or it's not supported, or it can be, it's not available but can be provisioned by admin. I think I cannot show the video that I posted here. I don't know how to.
Sorry, I'm not sure if that pasted properly. Sorry.
Yeah, yeah. Basically, it's when you go to the model page, ML Hub page, models page, which shows the 100 most models of Hugging Face API, and then you go to the models details. It shows a button, actually, inference server info button, which for the models that are not available, the inference server availability, it just shows the message that the server is unable to run the models and it's not supported. For the models that it's not available, but it can be asked by admin to initiate the inference server availability. It shows the message. It shows the message that you should contact the admin, and also it shows the transformer info. Which I had a video for that, which is not possible to show you. Also, the main datasets hub page was my next task, which was by setting up the routing path to render the dataset component. It displays the top 100 datasets with information on datasets ID, the number of the downloads, and Hugging Face, and the last modified version of them, and the Hugging Face. And it just shows all the details about each datasets and most downloaded datasets on the Hugging Face. The datasets, other one was the datasets. Dataset. This is like the datasets and detailed datasets page, which shows the that's ID, downloads, and last modified. And the other task, the last task, was to fetch a single datasets information, and by dynamic routing based on the datasets ID, and also to create a layout for 2 button placement, which was the datasets download dataset button and display dataset card. Also the details was like the author, the created ad, date, and the number of the versions, and all the details that is available in the Hugging Face, actually. Also, the downloaded datasets button shows the page that it goes to fetch all the URL file of datasets that are available in Hugging Face, and just triggered by and the download will be triggered by the button on the page, and you can download the data sets. And also the detail, display data sets card shows the display of the data sets card, which was annulment, like resource or tags of those data sets. My milestone was working with a large project like Tapis UI framework and learning the best practices of large software development projects, like guidelines, rules, the communication skills and practices that all software engineers do to communicate, and which was great. And I'm very grateful for that opportunity. I had some challenges like utilizing new languages, like learning model inference and datasets API, like which Tapis UI hooks to call to fetch the data, and Git code versions like branching, merging the new code, pull requests was somewhat challenging for me. And also like deploying the Tapis UI and MLOps somewhat challenging, but lesson learned. I was able to learn to use version control in large project and the guideline of it. And also I learned that VS Code sometimes fails to recognize the imported file. And when you have a lot of bugs, you might just restart the VS Code and it goes away. And always console.log and test your code before going forward. It helps to process it better. And my magic moment was when I had the insight that I got into the front-end development world. When feeling of accomplishment when the code works always is great, and when the code renders, it's always great. I want to thank my mentors, Nathan and Christian. They were very great and valuable. Always had a solid answer for all the questions that I had. I'm very thankful of them. I want to thank all the other mentors, Danny, Gilbert, and Anaka, for setting up the workshop for us, helping us, and answering our questions. I want to thank the PIs, Joe, Maysal, and Rosie, and all other tag members. You are so great and made this experience very pleasant for us. I want to thank my fellow SGX3 interns and friends like Sarah, Sajid, Sopranica, Viola, and Swati. I couldn't ask for better friends to have this journey with. And I want to thank SGX3 program and NSF for funding us and giving us this opportunity. Thank you.
Thank you. Thank you. What a wonderful presentation. Thank you.
Hello, everyone. My name is Zahra. I earned my bachelor's degree in computer engineering from the Department of Electrical and Computer Engineering at University of Tehran in Iran. After spending several years gaining experience in the IT industry, I came to the US to pursue a PhD in computer science. I was offered a position at Case Western Reserve University, where currently I'm working on a project that focuses on application performance anomaly detection and detecting performance anomalies in applications and applying AI techniques to enhance high-performance computing under the supervision of Dr. Vipin Chowdhury. During the internship, I worked on workflows and developed a set of front-end tools for iSQL project. The main components of the workflow was that we developed Tapis UI features in support of iSQL project. I developed a user interface within Tapis UI to facilitate the creation of ETL pipelines executed on Tapis workflows. The next slide, please. I'm pleased to share some of the tasks and milestones I accomplished during my time at Tech. I had the opportunity to learn the key technologies such as JavaScript, React, TypeScript, And one of my contribution was adding SCSS components and padding to the workflows pipeline sections. This improved the overall user experience. I also developed a collapsible component. Next slide, please. I also developed a collapsible component to efficiently render secondary sidebar systems. Another component is the create user credential modal for the systems toolbar. So we added a new button that opens the modal for creating user credential. I also incorporated fields and YAP validators into the modal to ensure proper data validation. Finally, we implemented system ID submission and public-private key validation, enhancing the security and functionality of the user credential creation process. Next slide, please. I have improved my skills in JavaScript, React, and TypeScript. Additionally, I have gained a better understanding of SCSS, which has been very helpful for styling and layout design. I also created a new features and capabilities as front-end development for the Tapis framework. I learned about the importance of the user experience design in creating efficient tools, which I learned it by adding collapsible components and models. Using the validators, I gained valuable experience in handling security features such as public-private key validation for creating user credential. And working closely with my mentors and peers, I learned the value of effective communication and collaboration in project setting. Sorry, next slide, please. I greatly benefited from the feedback and guidance of the mentors, which significantly improved the quality of my work. Next slide, please. As I mentioned, I had the privilege of interacting with mentors who were incredibly approachable and generous with their insights. I met so many amazing professionals at Tech. Their willingness to share their knowledge was truly inspiring, and my questions were answered with clarity and depth. Learning about the impactful work at Tech has inspired me to do meaningful contributions in my research field. Overall, the supportive community at Tech significantly boosted my learning experience. I want to thank you, Maytal, Nathan, Christian, Mike, Anaga, and Tracy for all the care and support they offered me. Thank you for your time and attention. I appreciate the opportunity to share my work.
Thank you so much.
Hello everyone, I'm Saubharnika Balasubramaniam. I'm a master's student pursuing computer science engineering at the Ohio State University, and my technical skills include machine learning, computer vision, and software development. Some of my hobbies include traveling, hiking, exploring new food places, and also playing badminton. Can we go to the next slide?
You should be able to control it now. We just had a little bit of an issue.
I can.
If not, I can manage it as well.
I couldn't go to the next slide.
Okay, no worries.
Okay. So the current team that I'm working on is ML Edge. It was real. Joe and Rich has been really helpful with most of the backend development, and we have been working together for around 2 years now. And for, during this internship, I met Nathan, Gilbert, and they were really helpful with the Tapis UI and giving an overview of it. And also, I would like to thank Samuel and Tanya from OSU. Can we go to the next? Yeah. So the main goal of a project is to deploy machine learning model onto the edge device. Now it's focused especially on camera traps, and in future we are also expanding it to drones and other devices. So some of the constraints that we are facing when we deploy a machine learning model to the edge includes the power consumption, the memory storage occupied by the machine learning model, and due to the limited availability of the resources, it is hard to deploy a new machine learning model with complex architecture directly onto an edge device. Thus, we are developing a simulation environment which helps to understand and analyze the different resource requirements for each models, and also optimize the models before deploying it into a edge device. So in order to do that, we developed a user interface where the users and researchers can select can choose the different data sets, a machine learning model, and also which hardware they would like to test. And the user interface initiates a simulation environment which processes the images, runs machine learning models onto it, and provides a resource requirements, which includes the memory, storage, power, etc. And the results will be displayed onto the dashboard. We also, during this internship, we also optimized several Python code, and we also added a monitoring plugin which helps to provide an idea of the number of images, ground truth information, image scores, and everything. So here's an overview of the UI design that we developed. It is hosted on Icicle AI dashboard, and we can see a ML edge. When the user or researcher chooses the ML edge, can we go to the next slide? Yeah. So the user is given with two options, like creating a new analysis or just viewing the report. So once the user chooses configure new analysis, the user can choose a machine learning model from the list of models available, or either upload a model of their own. And a list of data sets are available. The user can either choose from this or give a URL which is also available, and it allows users to select from a list of hardware devices like Jetson Nano, etc. And once the user clicks the analyze button, a job request is submitted. And the user is also given an option to make multiple analyses at the same time, and at the end, a comparative report will be showing like how the performance of the particular model at particular device versus other analysis that they chose. Can we go to the next slide? So once the user submits an analyze button, a job request is submitted, which invokes the system controller. Based on the input, it invokes the event engine, and the event engine is based on a plugin architecture. First, the images are retrieved from the data set, and the images are converted into binary format, and it is sent to the image receive plugin. Once the image receive plugin receives the image, it sends to the image scoring plugin. This is where the actual machine learning happens. So the machine learning model detects the image, performs object detection or species classification, and sends a score along with label. Currently, we are using a model called Meha Detector. It's a computer vision model which is developed using YOLO Wi-Fi. And based on the score and label, the image store or delete plugin decides whether to store the image or delete the image. And the user can also choose a threshold below which the image needs to be deleted. So all the activities, all the plugins are being measured for power by the power measuring plugin, and the logs are being monitored by the Oracle monitoring plugin. This was something that I worked through the summer, where it receives messages from each of the plugins and logs messages like image, ground truth, the scoring, and whether the image was deleted or scored, everything. And once all the information is logged, it sends an image terminating event, and this terminates all the plugins as well as event engine. Once the engine is terminated, the results are sent back through Files API, and it can be viewed by the users or researchers in the dashboard. Can we go to the next slide? Yeah. So some of the challenges we were facing was, this was the first time of me developing the front end, and I had some issues by while validating things and also adding new features. It took a while, but it was really a good learning experience. And while creating a monitoring plugin, it was accessed by multiple plugins. So we had some race conditions, and with help of Joe, I was able to fix it, and it was able to brush up my operating system skills. Can we go to the next slide? Yeah, so I was able to develop a good understanding of TAPIS framework. Nathan and Gilbert really helped a lot, and Christian's meetings were also super helpful. I was able to successfully develop a UI design using Node.js and TypeScript, and also integrate with TAPIS jobs and TAPIS UI and submit a job. With the project, I was able to improve my Docker containerization skills, and I gained a good understanding of execution of various plugins, passing of messages through sockets, and also the model architecture. Some of the magic moments include the successful creation of user interface, and when I made the submission, I was able to do the job submissions. And we tested the simulation environment to process around 8,500 images, and it was successful. And some of the magic moments involves seeing the sunset at Travis Lake and watching fireworks at downtown. And also I had a chance to visit NASA at Houston. So yeah, thank you so much. I had a really great experience, and ending with some of the foods that I tried at Austin. Thank you.
Thank you for a wonderful presentation. Your slide has now made me very hungry. Thank you.
Thank you.
Great work.
Hello, everybody. My name is Swati, and I'm a fifth-year PhD student at Ohio State University working with Dr. Rajiv Ramnath. And this is my second time. I think some of you guys have seen me probably in the last year. SGX3 experience presentation, and this is my second time being an SGX3 intern, and it was really great. And I'm also part of the Icicle project since its inception since 2021, and I've been working with Dr. Joe for a couple of months now. My primary area of interest is building AI-driven solutions for high-performance computing, profiling, resource estimation, and building estimators to overall improve the HPC utilization. This summer, I worked on something which is slightly different, which is an animal ecology use case. So as we have already seen Sobronica presenting a couple of examples from animal ecology use case and how we have been using TAPIS. So before I dive into the task that I've done, I want to paint a slight picture of what animal ecology is and how TAPIS could be used in this entire user-driven science. Imagine we have a forest, and animal ecologists are interested in understanding the synergy between an animal kingdom and its ecosystem. So they usually deploy edge devices like the one which we have seen in Sobronica's example, like drones or camera traps, which basically capture some images and they push those images to some cloud, like say OSC or TAC, where animal ecologists actually study the images to figure out if there's a human intrusion, if that is their area of interest. But then in this process, we see that there's a delay in like capturing the images and then analyzing the images. So in order to overcome this delay, animal ecologists deploy edge inferencing engines. So they deploy AI models on edge. And that's what we have seen in Sobronica's example, where the edge is actually capturing a couple of energy utilization pictures, etc. So here in this case, they deploy edge inferencing models. For example, let's say we are working with Mega Detector, which is basically a YOLO-based model for capturing, detecting images and doing classification. So in this example, we use a model called Mega Detector, which basically identifies animals and distinguishes it from vehicles or humans. So since we are deploying AI models, these models have to be constantly upgraded with either smarter and efficient models, or as and when new training data sets come into existence, they have to be updated. So hence we need HPC systems. So animal ecologists usually have access to centers like OSC or TAC, where they actually develop these AI models that are deployed onto the edge, either by using TAPIS or on demand. There are different platforms. But in order to update these models, we need more capabilities that need to be added to the TAPIS UI or other gateways. So for example, the animal ecologists move their data sets from their cloud into the center. And once they do that, before they fine tune their models, they actually have to label these images. They have like tons of images coming in from the edge devices that they have to manually look and label, like which image has an animal and what's its accuracy and so on. So for that, as part of this fellowship, we have introduced a new Tapas UI component, which is basically a data labeling engine. And after the data labeling happens, the user have to actually retrain these mega detector models that we see on the top right. You have to retrain these models, which are basically nothing but normal HPC jobs, batch scheduling jobs. So for that, we also tried to incorporate my existing research that I was doing as part of Icicle, which is basically building a scheduler which is on top of the Slurm, which is basically making the Slurm scheduler a smart scheduler. So how do we incorporate that, and how do we view the jobs that have been scheduled via the smart scheduler to the front end? And in the coming few slides, I'll explain more about these two components that I've worked on as part of this fellowship. So the two tasks that I worked on are creating two UI components inside Tapas UI. So one is for the labeling training data sets using Tapas UI, and the other one is viewing the jobs that were scheduled by the smart scheduler component of Icicle using Tapas UI. So the first question usually people ask is, why do we need to create a UI that helps users to actually develop training data sets for building AI models? So as Veronica has already showed us that we are using a tool called Mega Detector. And when we actually went ahead and wanted to use Mega Detector to retrain new models, as in when new training data sets come in, they recommended us using third-party software called RoboFlow or Vertex VI, which is basically a server where we have to log into their server, push our images, and then label those images using the models that are available on those systems. And as you can see in this slide, those models are quite expensive. And we have figured out that if we can actually bring in those capabilities into Tapas UI, we can actually reduce the cost significantly. For example, Veronica has a OSU small data set which has 1 million images. And if we have to actually use those images, it's going to cost us like around $1,000 if we use RoboFlow to assign labels to those data sets. But if we can enable Tapas UI to do the task, we can do it under $10. So, I mean, if we have time, I can show through the Figma UI at the end, but that's the primary goal of having a UI interface to enable data labeling using Tapas UI. And the second thing that we created is a smart scheduler. So initially, I'll give a brief overview of what is scheduling versus smart scheduling, like how are smart schedule jobs different than normal jobs. Imagine, I think most of us use HPC jobs, and here at TAC, if you see the maximum time you can request a resource allocation is for 2 days. But what if you have training loops that take more than 2 days, like maybe 5 days, 1 week, or 2 weeks? Then you have to schedule a job, checkpoint, or store the intermediate results, and then reschedule a job until you have those 5 days of allocation. So that's basically your routine workflow. But with the smart scheduler that we are building as part of the Icicle, the smart scheduler literally takes one big chunk of a job and chops it into tiny jobs, and it offloads the task of scheduling, monitoring, and rescheduling into a daemon which runs on any of the server systems, which is a lightweight daemon. And as part of this project, I've just created a UI that basically shows the progress of these jobs that are scheduled by the smart scheduler. So I've created some simulations, and I've created the UI that literally shows, okay, what are the jobs, what are the current status of the jobs that are scheduled as part of smart scheduler task. So a couple of significant milestones that I really wanted to highlight as part of this project is Figma. I usually use PowerPoint to create all the slides, but Figma has actually amped up my skills of creating UI and showing and picturing like what I want my UI to look like much efficient. And I familiarized myself with Tapas UI, and probably now I know, like if I have to create a new site component in Tapas, I can probably pull up existing Tapas hooks or UI components and then recreate a new Tapas UI component much efficiently. And there are a couple of other milestones. So I haven't worked with animal ecology projects so far, but this time I worked on an actual user-inspired science that made me use my existing smart scheduler work much efficiently. So I found out the pitfalls of my existing research and how I can make it more efficiently integrated with actual users like animal ecology use cases. So I think a couple of challenges that I really wanted to highlight, especially while working with third-party tools here. For example, here we're working with Mega Detector, which was created by Microsoft. Open source code was unavailable if we had to build retraining loops or if we have to fine-tune their code. Open source code was unavailable, and recreating open source code from their dataset was really challenging. So I think this is one of the learnings that we have to look, especially while using third-party tools, to make sure that we have sufficient source code to probably reuse their code or put their code in our workflow. And in a way, I felt like instead of using RoboFlow, if we are creating Tapas UI for data labeling, that's an added advantage, because let's say if RoboFlow decides to change their API calls or they decide to increase their cost, we don't need to rely on them. So that's one of the added advantages I've seen. And also reusing a couple of Tapas UI hooks instead of recreating everything from scratch was a little challenging, but I figured out ways of using existing Tapas hooks, existing UI components to create new sidebars or create new Tapas UI components. And I think one of the primary learnings that I had is like, we were in the very first week, like my other fellow interns, I also had to do JavaScript, React.js, and TypeScript trainings. And I think I have done JavaScript training after 10 years. So in my undergrad, like in 2010, I've done JavaScripting, and I've seen such a huge change in the world of JavaScript and how powerful JavaScript has become in the last 10 years, which was really motivating. So I took the tutorials back to my school, and I was telling all my grad friends, like, you have to do this JavaScript training, especially even if you have to build your website, because I've really felt the power of JavaScript in this learning. And I think one bad side of research to me is like, I always underestimate the amount of time it takes for a task. So I think I'm still improvising on how to estimate how much time it takes to do a task and not feel overwhelmed. But thankfully, I'll be still part of Icicle team for the next year. I have one more year of my PhD journey, and thankfully, I still have time to work on more of my components. So that were my learnings. And the magic moments, probably the first of the magic moments is this time the internship 9 weeks flew like probably 9 days. It was really quick and very efficient. And Texas is thankfully not as hot as I expected last year. It was almost, I think, above 100 degrees, and this time it's way better. And I was at PERC with Dr. Joe, Nathan, and Anaga last week, and it was really wonderful. I was part of the student program, and we also launched Icicle user group as part of PERC, and it was really insightful. And I'm actually very excited to do the SGX3 fellowship this time, and hope to see you guys at the Science Gateways. As all of our interns, we have, I think, submitted posters or portals this time. Thank you.
Thank you so much, Swati. What a great presentation. And yes, the weather was very kind to you guys this summer. Claire, I think there's one more slide after this. You can move that one. So I just wanted to really say a huge thanks to all the interns for your hard work. As everyone can see here, they accomplished an amazing amount in 9 weeks, which, as everyone has said, really flew by. Thank you to the mentors for all the time and dedication. There wouldn't be this success without a lot of the mentoring and being able to really explain and help and support the interns in their projects. Thank you everyone for attending this webinar. Feel free to follow up with me if you have any questions about our internship program or SGX3 services that we can offer you. And thank you again to the interns. I hope this is just the beginning of your engagement with SGX3, and we get to see lots more of you in the future. Thank you everyone for attending. Let's give the interns a nice virtual round of applause. Thank you. Bye everyone.
Thank you.